Could the universe have existed before the Big Bang? And what exactly was there before the universe as we know it began to expand? These questions might sound crazy, but they've caught the attention of not only scientists, but also the general public. Modern science uses the Big Bang theory to explain how the universe started. According to this theory, our world came from a massive explosion known as the Big Bang. This explosion happened because of something called singularity, a point in space-time where energy, density, and mass become incredibly high, while dimensions nearly disappear. A new perspective from Brian Cox. Brian Cox, a scientist, has shared a bold idea. He suggests that the universe has always existed and that the Big Bang theory might be incorrect. The Big Bang theory talks about singularity, where there was no space, time, or matter. But the question remains, where did the singularity come from? What happened before it, and what caused the countdown to the Big Bang? Was the universe eternal, or did it have a beginning? Exploring the fundamentals of life. Scientists, especially physicists and biologists interested in life's origins, ponder how everything started. Earth is home to a diverse range of organisms, and from a physicist's perspective, it's essential to trace things back to the very beginning. The image depicts the universe's evolution and origin as we currently understand it. The age of the universe. Recent precise measurements estimate the universe's age at 13.75 billion years. This suggests that the universe began around that time. However, the reasons behind its start remain a mystery. Questions about what occurred before the Big Bang are common, but the answer is currently unknown. It's a topic of ongoing research. The early universe's state. At the beginning, the universe was extremely hot, dense, and small. Everything we see in the universe today was once compressed into something possibly smaller than an atom. As the universe cooled, it began to expand. Over time, complex structures like DNA, stars, planets, and even people emerged. We have gained a good understanding of how these complex structures formed from the initial ball of energy 13.75 billion years ago. This expansion led to the creation of diverse things we observe today, like DNA, planets, stars, and even life. Time's behavior near massive bodies. Einstein's theory showed that time passes slower near massive bodies. For instance, Earth's substantial mass causes time to move slower on its surface compared to an astronaut in orbit. This was proven by American scientists Robert Pond and Glenn Repka in an experiment, where clocks on Earth's surface ran slower than those at a height. This matches the theory of relativity's prediction. The singularity in Einstein's perspective. Before the Big Bang, the cosmic singularity held all the universe's mass, effectively stopping time. Einstein's view suggests that discussing what happened before the Big Bang is meaningless as there was no before. However, this challenges the concept of cause and effect relationships, which are crucial in physics, where every effect has a cause. Support for the Big Bang theory. The Big Bang theory finds support in evidence such as the universe's expansion, discovered by American astronomer Hubble in 1929, and the cosmic microwave background radiation, discovered by American scientists Penzias and Wilson in 1965. This radiation appeared 379,000 years after the Big Bang during the era of hydrogen recombination. The epic journey of the universe. The Big Bang theory proposes that the universe, once as small as an atom, went through various epochs. These include the Planck epoch, the Grand Unification epoch, the Inflationary epoch, the Electroweak epoch, the Quark epoch, and the Hadron epoch. These stages shape the universe's fundamental forces and interactions. A breakthrough in science. Astrophysicist John Greben described inflationary quantum cosmology as the most significant advancement in science since Isaac Newton's time. This theory addresses the singularity problem and the concept of nothingness before the universe's creation. Quantum fluctuations in creation. Quantum theory allows for particles to emerge spontaneously from a vacuum. Cosmologists wondered if the universe itself could have emerged from a random quantum fluctuation. This could explain why there's something rather than nothing. Questions remain. The universe's emergence from nothing challenges conventional thinking. It raises questions about the true randomness of the quantum fluctuation and its implications. Fundamental constants and three-dimensional universe. Physicists noticed that even slight deviations in fundamental constants would prevent our universe's existence. Additionally, the universe is three-dimensional despite mathematical models suggesting 4 dimensions. This has led to speculative theories about additional dimensions. Multiple dimensions and their impact. Considering the possibility of multiple dimensions, physicists ponder how forces might be confined to certain sheets of space. leading to potential universes right next to ours. Such ideas are speculative and suggest that our universe might be just one sheet in a larger cosmic book. The anthropic principle, observers shaping the universe. The anthropic principle proposes a fascinating concept that observers like us possess the potential not only to influence the universe, but also impact the fundamental laws that govern it. This principle comes in two versions, the weak and the strong. The participatory anthropic principle, observers' impact on reality. A variation of the strong anthropic principle is the participatory anthropic principle. According to this idea, phenomena doesn't come into existence until they are observed. This perspective implies that observers play a fundamental role in giving meaning and substance to the universe itself. However, this concept is not universally accepted within the scientific community. Alternative ideas, cosmological natural selection, and second universes. In the scientific community, an alternative concept called the theory of cosmological natural selection, or second universes theory, is a topic of ongoing discussion. This theory suggests that each black hole within our universe could potentially give rise to a new universe on the other side. These newly formed universes might possess different sets of fundamental physical constants compared to our universe. It's in these alternate universes that conditions could be just right for intelligent observers to emerge. Brian Cox's insight, pre-Big Bang universe and cosmic inflation. Physicist Brian Cox, known for his insightful explanations, has introduced a thought-provoking idea. He suggests the existence of a time before the Big Bang. Cox's concept aligns with the theory of cosmic inflation, which proposes that the universe underwent rapid exponential expansion in an extremely short time span shortly after the initial Big Bang event. This inflationary growth resulted in the universe's remarkable uniformity and smoothness, explaining its observed consistency at large scales. Roger Penrose's Aeon theory, cycles of creation and collapse. Roger Penrose, a renowned mathematician and physicist who earned the Nobel Prize for his contributions to black hole understanding, has introduced the concept of aeons. According to this cyclical theory, each aeon begins with a Big Bang, followed by an era of expansion and then contraction. The cycle culminates in a Big Crunch, where the universe collapses back into its original state. This process sets the stage for a new eon, and the cycle continues indefinitely. Exploring the multiverse hypothesis. The multiverse hypothesis posits the existence of numerous universes, each with distinct physical laws, constants, and properties. This idea stems from the belief that our universe might be just one of many in a vast and diverse multi-universe. The concept gains traction as an explanation for our universe's finely tuned conditions for life. Scientists observe that fundamental constants and physical laws appear precisely balanced to support the emergence of life. The anthropic principle suggests our universe appears this way because it must sustain intelligent observers. The inflationary multiverse theory. Within the multiverse hypothesis, the inflationary multiverse theory stands out. It proposes that cosmic inflation, a rapid expansion shortly after the Big Bang, led to the formation of bubble universes. These universes have different physical parameters due to varying expansion rates. While intriguing, the multiverse hypothesis faces challenges due to the lack of direct empirical evidence for other universes. Critics argue that it remains untestable speculation and lacks the empirical validation required for scientific theories. Despite challenges, the multiverse hypothesis captivates physicists and cosmologists. It offers potential explanations for cosmic puzzles, such as the vastness of the universe and the nature of reality in the quantum realm. String theory, suggesting higher dimensions, also connects to the multiverse hypothesis. While ongoing debates continue, the multiverse remains a valuable thought experiment in cosmology, encouraging scientists to push the boundaries of understanding. What are your thoughts on this mind-bending concept? Do you think the universe could have existed before the Big Bang? Do let us know in the comments below, and as always, don't forget to subscribe for more thought-provoking discussions.